All right, I'd like to welcome everyone to this GigaOM webinar, Cloud Data Lakes, Data Warehouses, and Data Prep, making them all work together. And let me just point out that data prep, although third in the list, is actually first in our mind here. We want to talk about the role data prep plays in, yes, making these things work together, and also where necessary and where appropriate, preserving certain distinctions between these things that come together. Our sponsor today is Trifacta. My name is Andrew Brust, and again, I'd like to welcome everyone here. I cover data and analytics and more machine learning, and for that matter, even BI, business intelligence, as an analyst for GigaOM. I am also someone who covers that same space in writing for ZDNet, and my own background in this technology is 20 plus years old, going back to some of the earliest BI systems, and even further back than that with database technologies and so forth. Our guest, who we're very lucky to have here today, is Wil Davis. He's head of marketing at Trifacta. If you didn't know, Trifacta is really a pioneer in the space of data preparation. And beyond that bit of flowery introduction, Wil, I was hoping you could fill us in with, kind of some of what your day-to-day involves, and also some of the things you did before you came to Trifacta, just so we can appreciate your perspective.
Yeah, thanks, Andrew. So yeah, I head up marketing globally at Trifacta. I've been at the company for close to 6 years now. We operate in North America, EMEA, and also APJ and Latin America. So we have a global presence and have customers in all of those geographies. Prior to Trifacta, I have been in the data management analytics space for well over 10 years. Whether it's in data infrastructure, I spent a few years at Greenplum that then turned into Pivotal after the EMC acquisition and integration of multiple companies. I've also spent time at ClearStory Data on the data visualization and analytics side, and Good Data, which is similar in that realm. So I've sort of played a role in every layer of the analytics stack, from the infrastructure to the end consumption analysis, and now at Trifacta, playing in between those areas in the space of data preparation and data pipelining and getting data ready for analytics. So Andrew, it's really exciting to be able to present with you, having worked with you both in your capacity as an analyst and a member of the media. So excited to be here. Thanks for having me.
Excellent, and thank you, because I know when I kind of ask guests to give us a little bit of their resume, it seems like a bit of a formality, or you're filling out a form, but that's really useful to understand that you spent a chunk of time at Greenplum, which is probably, speaking of pioneers, one of the important pioneers in the columnar in-memory data warehouse space, and that you were also at places like ClearStory and Good Data. So you really have been on both sides of the spectrum that we're going to talk about today. Great to know that. Okay, so in broad strokes, what we're going to talk about, first of all, is that distinction. And just as a preview, the distinction can be blurry. That's why we want to talk about it and see what we can map out and get a kind of definition of consensus. It is the case that data lakes and data warehouses more and more are at least trying to take on the workloads of the other. That makes the distinction a little bit hard to keep in mind sometimes, and I think that's worth exploring, and also not in a way where we're going to be judgmental and say these definitions are wrong or right, but let's just try and be empirical and understand the differences. Let's talk about then various options for getting data moved and transformed. Some might call that ETL, some might call that data preparation, some might call that whole thing data pipelines. Maybe we'll even have a chance to talk about some of those semantics. We'll also then talk about what the advantages of a dedicated data prep platform are, because, there are ways by the seat of your pants to do data movement and transformation without a dedicated platform. So what really are the differences in value there? We'll talk about that. We'll also then discuss how data prep isn't just about moving data between lakes and warehouses, that actually there are elements of data governance, and there's great applicability to machine learning and AI. We're also going to have a couple of polls as we go along, and this is really a great opportunity for us to be selfish, i.e., we get to understand a little bit more about those of you in the audience and kind of where you are in this journey with lakes and warehouses, and your approach to data integration and transformation. And so we'll have those, and we'll quickly kind of discuss if we see anything that looks, surprising to us, or if it seems consistent with what we might have expected. Q&A is also welcome as we go along. You'll need to simply use the GoToWebinar console, enter your questions through it. The good folks at GigaOM will relay those to us, and I will do my best to weave them into the discussion. To the extent that it's needed, we may have to leave some until the end, just to keep the pace. But it's my great hope that we can take these as they come. So that's really it for preliminaries. And here we kind of go in earnest now to understand the framework of the discussion, if you will. Lakes and warehouses, are, again, while each one, at least rhetorically, seems to be talking more and more about handling the workloads from the other, there are, and we'll find out from the audience what the reality is, but there are lots of organizations with both. And at a very high level, it seems that lakes are all about kind of a landing place for informal data analytics, where we don't have to worry too much about structuring the data. It's a good place for raw data to land, and for us to do, as I said, kind of exploratory analytics. The warehouse is a place of more formality, where more repeated analytics can happen. And that said, these are probably not hard and fast definitions, but what do you think of that distinction? And what do you think about the fact that on this slide, data preparation is right in the middle of all that?
Yeah, so I think over the past few years, whether it was the rise of Hadoop and now more so the cloud data lake, this ability to ask questions of your data in a way that went outside of what was in your operational data store or your enterprise data warehouse has been a key strategy for organizations. And I think, the unknown unknowns or exploratory analytics or whatever you want to call it, companies see massive value in being able to get at new insights, new combinations of data that can give them competitive advantage over other companies in their industry. And so that is where the value of the data lake, or even the concept of the data lake deployed within a data warehouse, is happening. And this was one of the big drivers for the founding of Trifacta, is as all of these massively diverse sets of data get ingested into these lakes. How do you then make sense of that data? How do you explore that data, clean it up, bring it together, and do that in a very rapid fashion so you can get value out of it that can be drive business decisions, feed applications, and things of that nature. And so, I think some of the things that we were focused on in the founding of the company was making sure that you get diverse set of eyes on the data. So, traditionally in data integration or ETL processes, the individuals that were doing that work were probably not tightly connected to the business questions or the business context around the data. The process traditionally would be, hey, I want to do some analysis. Let me hand over to my ETL developer IT guy a set of requirements. They'll code it up, and then I'll get a set of data months later. That type of process, whether it's the speed, the accuracy, and just the rigidity of that, just doesn't work in modern business today. So what if you could give, hey, Mr. Data Analyst or Mr. LOB Manager access to, raw data that they can then explore, transform, and get into a state that's ready for analysis. They can rapidly iterate, leverage the context that they have around the data to do that, and then collaborate on that process with their colleagues. There's a ton of value in that work. And if you look at what a lot of people are writing about in terms of self-service and in terms of getting value out of analytics, the biggest bottleneck in this whole process is getting data ready, cleaning, prepping, blending, all of that work. And if we're able to accelerate that process, then the value of analytics that you can drive is just going to be exponentially more valuable. If you can get more eyes on that data and more collaboration happening, then, once again, you're going to develop new insights that you couldn't have ever developed in past experiences. And so I think this democratization of data pipelines is really what's going to be fueling this next decade of analytic innovation. And, we're excited to be on the forefront of that.
Excellent. So a couple of things there. First of all, things have changed, right? You mentioned Hadoop. You alluded to that. It was all about that for a while, and we've kind of swung to the other side where there's been sort of a Hadoop backlash, and now what it's all about, it seems, is data stored in cloud storage. But really, how much has changed? And I'm going to ask you to hold off answering that for just one moment, while I also say that initially it seemed the warehouse was very IT controlled, and a lot of business units maybe were frustrated that the data that they wanted to analyze, couldn't make it in there, didn't meet whatever standard was involved, and therefore they couldn't get the insights that they needed. And so the lake was in some ways, what we're now calling the lake, was in some ways a workaround. Actually, that workaround goes back decades. We used to jokingly refer to things as spread marts as opposed to data marts, where people were keeping a lot of their own data in spreadsheets and doing the analysis that way. But so it started maybe as a bit of a rogue thing, but it seems like at this point we're at an equilibrium where the lake's not rogue, it's legitimate. The warehouse is not viewed, hopefully, as some stuffy, now irrelevant thing, that each one has its role, or at least it seems that way. So to the extent, that I just maybe put words in your mouth or kind of, I'm asking a loaded question, I apologize. But what do you think of all that? Both the transition from Hadoop to, post Hadoop, if you will, on the one hand, and also this notion that big data / data lakes started as a shadow IT kind of activity, but now have more acceptance.
Is now the appropriate time for me to answer, Andrew?
Yes, it is. Sorry.
Okay. So on the Hadoop front, I think, with anything that sort of breaks through to a new realm, the probably first iteration of that isn't going to be the one that wins. So I think that the Hadoop brought a whole new mindset to how organizations could work with data. Now, I know there's been this huge backlash on Hadoop, and I'll cover that in a second, and huge backlash on the term big data and what that means. But I think what that brought forward is that organizations, that data intrinsically had value. And you may not understand that value. Your organization might not understand that value at this moment. But if you're able to sort of put that data in a place where people can access it in a flexible manner and work with it in a flexible manner, then at one point, you will find use cases and analytic value out of that will be valuable to your company and will drive competitive advantage. And so I think that realm of thinking, in terms of instead of saying, hey, we have a core set of KPIs that we run through our BI implementation and our data warehouse that are going to be the things that we focus on, and then there's exploratory stuff that we can use Hadoop for. I think that was a very unique idea, and one that I think a lot of companies grabbed on to and tried to implement. I think some of the challenges with that have been just the technical nature of the technology itself. Hadoop being this open source technology with multiple components, and it became this realm more of Hadoop developers and administrators that were sort of stitching together distributions and technologies versus like actually getting to the data and getting business value from. I think that the average analyst or business stakeholder was so far removed from the Hadoop environment that there was a lot of pain with that in organizations, and they became almost science projects versus actual, business critical implementations. So I think like the mind shift was huge, and that thinking that big data and Hadoop brought on was a great transition for the whole business world, but the technology had limitations, and how it was implemented within organizations had a lot of limitations in terms of how successful that could be. Does that answer your question?
It does. And I had some follow-ups, but I want to get into our first poll, and maybe while we're waiting for people to vote in, we can talk a little bit alongside that. So we just want to kind of understand where you folks are in terms of adoption around data warehouses and data lakes. Do you have one, both, neither? And to the extent that a lake is in place, how formal or informal is it? And by informal, we mean, it's basically it's a bucket in the cloud, or it's some storage on premises where a bunch of files have landed, versus something that has more governance and maybe more formality to it. Zones may be laid out, or there may be policies, or we'll kind of leave it up to your own interpretation. So pick the one that best describes your environment. And we'll give you folks a chance to get that done. And gosh, the point I had that was buzzing around in my head, I think I lost my train of thought on it. But oh yeah, I remember. I think one of the most liberating things about Hadoop, and maybe you could comment on this since you were at Greenplum, a lot of data warehouses, were kind of sold in appliance form factors, appliance hardware, where storage was finite and highly monetized. At least it seemed that way. And Hadoop changed that equation and said, storage is going to be commodity now, and you shouldn't have to kind of live in fear of running out of it. You can just add more disks. To me, that was like the biggest contribution of Hadoop, even if we're not, using Hadoop and MapReduce today. Does that sound credible?
Yeah, I mean, the barriers to entry were much lower, right? You had commodity hardware, off the shelf, seemingly free software to be able to do some of this exploratory work. So yeah, when you are investing in an initiative in a business that, maybe you start off with no intrinsic ROI, it's going to need to be cheap for it to get funding. And so I think that benefited a ton versus if you're doing an EDW, whether that's Teradata, whether that's, following the acquisition of Greenplum buying EMC, we sold physical appliances. You're going to need to really have a business case internally of what that looks like. And Hadoop was had a lot of benefits to that. And you're seeing that to an even greater extent in cloud now. Like I can spin up a cloud instance on my credit card and expense that right now.
Even cloud, data warehouses in the cloud have infinitely expandable storage. So the Hadoop credo kind of made it over to the data warehouse side too, right? Sorry to interrupt.
Yeah, absolutely, and done it in a way that taking the advantages of that architecture and the cost effectiveness of that and just double down on it. And I think that's why you're seeing organizations adopt cloud, because it's more agile, it's more cost effective. You can spin up, spin down. I mean, there's so many advantages to that's why you're seeing the explosion in these ecosystems of AWS, Google, and Azure just happening seemingly overnight.
Yeah, makes sense. And I think what that means is we got to move away from the period of be really judicious about what you store and analyze to be really judicious about actually getting rid of anything and and determining it unworthy. It could always
Totally.
come in handy. It wasn't affordable before. Now it seems like you can't afford not to. If I can use the double negative on top of one we had earlier. So all right, I think at this point it might make sense to have a look at the results of this poll. So we can quickly comment and move on. And the results are very clear on my side. It looks like the winner, if you will, is we have a data warehouse and an informal data lake. And another 25% have a data warehouse and a formal data lake. So that is more than half who have both. And we do have a non-trivial component of folks who have neither. So that is my cliche question when we do these things. But any surprises here, or also just anything that makes you kind of excited or encouraged?
No, this looks around where I would expect the answers to be if I were to think about where the market is headed. I mean, having a formal data warehouse and then having this exploratory lake that is informal and process. I mean, you sort of want it to be informal to a certain degree in terms of enabling self-service, enabling exploration. I guess what I would love to hear is how you would describe a formal data lake versus an informal data lake. I think you touched on that a little bit in the preamble, but I would love to hear your take on the difference between those two. Like one wears a tie and one doesn't. Yeah.
Yeah. I guess it's a question about whether there's architecture and forethought around how the lake is structured versus it just being, a place, as I said, where it's really just a storage volume for data files. And we could nitpick whether there's even a distinction there, but I think the important thing to note is that over 50% of the organizations represented by our audience here are in the world of data lakes, and so people may say Hadoop is dead, but the Hadoop ideal, I think, has now seen really important levels of adoption. I think that's important. But let's be honest here and mention the fact that even in a lake, right? Even if it is just a bunch of files in an S3 bucket or on some some shared storage volume in the enterprise. We have these formats like Parquet and ORC where we can store even our raw data in a columnar format. And for those who don't know, you store all the values for a column together, and you're able to aggregate those that much easier, which is typically what analytics is all about. You're also able to get high levels of compression, which means you can fit lots of data in memory. And that's that was a big thing in BI, moving from where everything was stored in a row format or in a cube format and on disk. That was a proverbial game changer. So the lakes can do that, and meanwhile, folks are also spinning up data warehouses, not as the enterprise data warehouse, but something more project oriented, more workload specific. And if that wasn't confusing enough, we've also got the fact that a lot of cloud data warehouses are using the exact same cloud storage layers as the lakes. They're using S3 on Amazon or Azure Data Lake Storage or Google Cloud Storage. So with all that mushing together, Wil, is it too doctrinaire to say these things are different, and that difference is worth preserving? You alluded to it a little bit when you talked about kind of having a place for experimental work, versus, perhaps more, more governed and formal and predefined work. But I'll shut up and let you talk.
Yeah. So I think it's company to company. I think one of the interesting developments that we've seen over the past year has been within cloud data warehouses, whether it's a Snowflake, BigQuery, Redshift, Azure SQL Data Warehouse. There has been a big movement in towards of companies moving data to a warehouse and then transforming it once it's in the warehouse. So I think in cloud, whether you're using a data lake architecture or data warehouse architecture, the pattern that we see most often is both data movement, whether it's from an on-prem system, applications, multitude of those things, into an environment. So that could be an S3 lake, the other lake stores that you mentioned on this slide. It could be a Snowflake, and then transforming it for use or preparing it for use once it's in that environment. The whole concept of, building a ETL pipeline, before it lands, I think we haven't seen that as predominant within cloud as, we saw in past generations of this. I think that what organizations are doing is, hey, let's bulk move data, let's land it, let's have the raw fidelity of the data, and then let's refine in that environment for use based on needs. And, depending upon the organizational structure and the technology you're using, that can easily be done in a data lake environment. And typically how we define a data lake environment would be, let's say the AWS context would be S3, some sort of processing layer, whether that's EMR or something like Databricks, and then an analytic layer, which could be anything from Redshift to Aurora to even, pushing back an S3 and running queries against that on Athena. Or, you could be doing a similar approach, just to landing raw data in your Snowflake instance, transforming it in that for use, and then running analysis off of that as well. So I think it depends on, once again, the technology the organization is implementing, architectural needs around, scale, throughput, things of that nature, and then how quick the cycle times are in that process.
All right. And I think what I hear you saying is that, and it's further acknowledgement of what we were saying before, which is that you can take on lake-like workloads in the warehouse, or even warehouse-like workloads in the lake, but there's still the conceptual distinction between a zone for doing experimental work on less structured data and more rote, but still highly necessary and highly structured analytics, on the other hand. So even if you're actually doing both on a single platform, on a single tech platform, there's still kind of distinct mindsets, and data prep is still going to be the invaluable kind of critical link to having both, and to being able to move one from the other. Because really, I think of the experimental places, that's where we're liberal. That's where we include everything. That's where we hopefully discover things that we didn't realize we even needed to ask. And then that's kind of a scouting ground or a proving ground. And then things may kind of graduate and move over to the more formal side.
So, in our experience, there's a guy we work with named Darren Chinnan. He's at Malware Bytes. They're a customer. And they have this concept of, they use this metaphor of mining in the stages of their data lake. So it goes from, let's say, coal to bronze to silver to gold to diamond or platinum. And those are sort of the stages of refinement of the data lake, where, as you move down that process, data gets into more refined or analytics ready manner. And in the beginning, it's very raw, and then it gets, as the exploration or the different stages take place, data sort of takes shape, and you can actually ask questions of it. But there is value in having the rawness of it at the beginning, so you can sort of have infinite questions you can ask, and then those questions become smaller and smaller as you move down, and become more focused as you move down that process. So I think lake architectures, if you have like a formal set of stages like that, that you've set up internally, then I think a lake architecture can lend itself well to that. But then if you have more ad hoc or fewer stages, then maybe a warehouse would be a better fit. That's probably one thing that I've seen in the working with our customers that seems to be relevant for that question.
Okay, fair enough. And let's continue now. All right. Well, now that we've kind of established that, at the very least in mindset, there are distinctions to be made between lake and warehouse, and that, doing some kind of movement and transformation of the data is critical to moving from one to the other. There are lots of choices here. ETL, extract, transform, and load, versus doing the load first and then the transformation. Some really obvious ones like on-premises or hybrid versus cloud only, self-service versus a more, data engineering approach. And that really alludes to the one that immediately follows it, which is hand coding the stuff versus using dedicated platforms. And of course, there's the fact that there is data prep, kind of functionality that's built into lots of products now, including BI products. So, gosh, I've been glib and unhelpful here. I've just listed a bunch of problems, a bunch of choices. Can you help us navigate through this, this mess that I've now taken inventory of?
Yeah. So, I guess I can go down this one at a time. So, in terms of the approach to, adopting a data warehouse or data lake architecture in the cloud, as I mentioned previously, we're not seeing a lot of companies transform data on the fly as it moves into an environment. We're seeing commonly in cloud environments, organizations moving data to some sort of lake or warehouse in bulk, and then doing the refinement or transformation once data lands there. In terms of the terminology and technology, it does get very blurry. We see a lot of traditional ETL technologies being used for that bulk movement of data. So that could be something like an Informatica, Talent, and then more emerging companies like StreamSets or Matillion and Fivetran to bulk move data into some environments. Once it's there, the transformation or preparation of data can be done in a system like Trifacta. So, once you've landed data, you refined it for use in that environment. And I think you're going to see as we move along, those two technology areas converging. So, Trifacta and data preparation companies like us will be adding more and more capabilities around both data movement and ingestion to handle that side of the business. And I think you're going to see, on the other hand, more of these traditional ETL or data integration companies provide a better user experience or provide more transformation functionality in that. And I think, like, in terms of our eyes, in Trifacta, we think it's far easier to move in the transformation or in the data movement game because it's somewhat of a commodity from a technology perspective than it is to move into providing a user-centric view of transforming data, which is, can be very difficult. So, whether you call that approach ELT or, just the separation of data movement and transformation, I think that's what we see most in the cloud. On these other topics, majority of companies are on a cloud journey. And so that journey is going to take, depending upon the size and scale of the organization and what their infrastructure looks like, it's going to take years. So you're going to want to be leveraging, and you could probably call that hybrid for the next few years. There are a lot of companies that are never going to move fully in the cloud. There are companies that will, but every company will be leveraging cloud in some shape or form. And then I think a lot of companies are moving to cloud-only architectures. So that transition will cause a lot of companies to be hybrid during that time. And you want to make sure you're leveraging applications that allow you to seamlessly move between on-prem and cloud environments. So one of the unique aspects of Trifacta is the ability to support both an on-prem environment like Hadoop and also support cloud-native environments like on AWS, on Azure, on Google Cloud. So that's something that from an application and architecture perspective, you want to make sure you're leveraging technologies that can cross over both environments. Self-service and data engineering. Once again, the focus on the problem, which is the bottleneck. If you only have a few people that can build data pipelines and serve up data for different analysis, you're always going to be dependent upon those few people. And so I think the democratization of data preparation or data pipeline development is critical to making sure that your scale and let's say, variety of analytics is being handled. And so, key to our approach is enabling a broader set of users that don't understand maybe Python or Java, that aren't ETL developers, to be able to do the work of accessing, preparing, and bringing together multiple data sources for use in some sort of analytics, and doing that in a governed fashion is critical to what we think organizations need to gain competitive advantage with data moving forward. Hand coding versus platform approach. Andrew and I were talking about this before the webinar. There are limitations to not only scale of data, but also just scale of sort of operationalization of hand code. You can only take a Python script so far, and so at some point when you're enabling broader usage and broader organizational adoption of these technologies, platforms in the end are always going to win out in that scenario. Embedded versus dedicated. My quick answer to this one is, hey, every company we work with has 20 BI and analytics tools in each department. Do you want to have 20 different data prep tools feeding each of those? Probably not. So, the focus on having a dedicated system that is the translation layer from raw data to some end consumption is incredibly valuable. And you've seen this happen in different areas, where Informatica, let's say, became that single platform that sort of integrated with everything upstream and downstream from that. And I think you're going to see that in the data preparation and pipeline space, that you're not going to be able to leverage embedded technologies across the organization, because then you're going to have 60 different tools across the prep layer and the analytics layer. There's going to have to be some standardization in that refinement zone to make sure that you have common metadata, common management, and common operationalization of different pipelines that feed various different downstream tool sets. And then commodity versus value added. Do you want to remind me, Andrew, the basis of that question?
Yeah, and actually it's not all that different from the embedded versus dedicated, or maybe embedded versus dedicated is one instantiation of it. In other words, there's built-in functionality. There's, I already have the tools I need to write scripts. I can get by on a kind of austere approach to data integration, or I can look to a dedicated platform. I can that perhaps makes that more productive or more reliable. That's really what we're talking about here. Do you go with an approach where you're using stuff that's perhaps free and already integrated with some other tool you're using, or do you look at a dedicated platform for getting it done? So to some extent, you've already spoken to it by talking about the embedded versus dedicated, but if you have anything to add there, by all means.
Yeah, I guess the only other comment I would have there would be, trying to leverage something that is, tacked on to a broader platform, a lot of times doesn't enable you to get your job done. I know, full stack integration, there's value in sort of having one engineering team that integrates all these technologies. Oftentimes in reality, they're products of acquisitions, and, engineering isn't really integrated, and your ability to get your job done end to end is going to be challenging leveraging those platforms. So we obviously are supportive of purpose-built technologies for specific areas that are going to provide best-of-breed capabilities that will enable you and your team to get your job done most effectively, versus trying to take on something, an entire process all in one platform that may or may not be great at every aspect of that workflow.
Sure. All right. Well, that all said, heterogeneity is probably in some ways the lifeblood of the technology world. So we recognize that folks out there, you folks out there, are going to have a collection of things in your environment. So here we're asking you to check all that apply. What kinds of data integration, data pipeline, tooling, and technologies are you using in your own organizations? ETL, NELT, or I should say and/or, scripts and notebooks, embedded data prep functionality, cloud data pipeline systems like, perhaps Amazon Amazon Glue or Azure Data Factory, or and of course dedicated data preparation platforms. So go ahead and vote in, and we'll get a sense of things, because I'd be shocked if we found too many people who answered yes to only one of these. I think just because of legacy and because of mergers and acquisitions and changes in trends, you're going to find environments that are a tapestry of these things. So hopefully we can get a sense. And wow, it looks like lots of people answered very quickly. We'll just give this about maybe 10 more seconds and then ask for the results to be brought to our attention. And then we can continue on in our conversation. All right, so why don't we go ahead and show those results, if we could. Here they come. All right, lots of ETL and ELT. Scripts and notebooks come in second place at 60%. Remember, these are going to add to more than 100 because it was check all that apply. Cloud data pipeline, wow. I wouldn't have expected that one to be necessarily as big as it was. Amazon Data Pipeline, by the way, is another service in addition to Glue that's germane here. Google Cloud Data Prep, of course, is in fact built on Trifacta's technology, so we should mention that as well. And dedicated data prep, we have a good third with that one. So once again, any surprises here?
I mean, for me, I think, I would say where we are going, so this concept of data preparation or cloud data pipelines is ETL and ELT. So it's interesting to see how people self-identify with these different terms, and probably not surprisingly, use sort of how the industry has referred to these processes for years and sort of what they leverage and what they use. And they're probably the technologies that fit in those categories for what they leverage. But I think like in terms of innovation and where this market is going, I would say, whether you call the technology a cloud data pipeline, you mentioned Google Cloud Data Prep, that is by Trifacta, or dedicated data preparation, I would say, those technologies are definitely converging with ETL and ELT in the cloud. And, it's going to be interesting to see how legacy vendors, ETL and ELT vendors, are able to adapt their architectures to be cloud native and to leverage native cloud services as more and more of this work moves into the cloud, versus some of the new age vendors, whether, once again, you bucket them in cloud data pipelines or dedicated data preparation, that are sort of built from the ground up to fit into those architectures and have native storage, native processing, native security built into that. And I think that is where this space is going to get very interesting over the next year or two, to see how that evolution happens and what vendors rise to the top.
Yep. And forgive my itchy trigger finger for moving to the next slide. That was actually a little bit accidental, but it's okay. We want to keep to a schedule here, but we do have ample time. And, just a few of the advantages of working with dedicated platforms are listed here. I just want to go out and maybe go out a little bit on a limb, but I don't think it's that controversial to say that most organizations with an in-house technology team and culture are gonna have a lot of hand-coded scripts and so forth to get this stuff done. It just seems to kind of sprout up in an ad hoc way, and sometimes the folks who are most involved with the data, the shortest path between their thoughts and something executing is to write down some code, right? It is imperative. The joke I had a zillion years ago with one of my computer science professors was, this was back in the days when, just to date me, when word processors that were so-called WYSIWYG, what you see is what you get, word processors, were kind of new and all the rage. But, the older approach was to actually embed commands interspersed with your text to get your your document formatted. And I had one professor who referred to that as yafigi, which was you ask for it, you got it. For a lot of technical people, putting some code down makes the most sense, right? It's what's going on in their head anyway, and sure, then that can be version controlled, and that can be executed. By definition, it can be scripted because it is a script. But ultimately, there's probably going to be, if you're working on a real platform, ultimately you're going to get to the point where you have greater durability for packages and jobs to run and be managed, and also to be maintained and modified. And that those modifications seem to become more and more required, because we're getting to a world where our schemas change, and we're tolerant of those changes. So, and even there, and maybe you can talk about how this may or may not be the case with Trifecta, even on platforms that make some of this stuff easier, there's still ways to, be extremely creative and express yourself, and express your kind of requirements with as much flexibility as a programming language might provide. So, again, I'll shut up and feel free to kind of speak to any of that you found germane or interesting.
Yeah, no. So, I think one of the, when I talk to people that are pretty familiar with this process, and they ask me, what is unique about Trifecta in this realm, my simple answer is you get to see the data while you're transforming it. That's the benefit. So, when you're working within an ETL pipeline or a mapping-based interface, you're sort of abstracted from a lot of the raw content of the data. And so the only way for you to understand the impact of the different transformations you're applying to the data is running an actual job and then seeing the output of that job. In Trifecta, you're actually in the data, building transformations, interacting with the data to get some of the recommendations and predicted transformations that you mentioned here. And then every time you apply a transformation while you're building your, what we call a recipe, but you can think of it as a script or a workflow, you see the impact of every transformation, how it impacts the data while you're actually developing that pipeline. And that is one of the unique value props that we have, is this unique user experience where you interact with an element of your data, you get a bunch of transformations, you select them, you see the impact that those transformations have on your data, and then you can accept, reject, or edit that as you build your pipeline. And I think a lot of the differences between that user experience versus other technologies is the rapid iteration, the agility, and also the cycle time. So your cycle times are going to be way tighter, way faster, and your data is going to be way more accurate with that type of model versus some of the other approaches. And the stuff on the ends we think is more commodity. So, data movement, operationalization, orchestration, that sort of thing. That's all stuff that's been done for 20 or 30 years that, any data integration system can have. But actually being able to explore your data visually, iterate on it during the pipeline development and build fast cycles, that's probably the only unique innovation that's been happening in this realm. That's of extreme meaning that we think is incredibly valuable for a lot of organizations, and not only enabling a broader set of people to do this work, but also enabling faster cycle times when doing it. And then to your point, making sure that can be very, very creative and exploratory of nature, instead of just, going down a simple path.
Mm-hmm. As I waxed nostalgic, you were making me think of, some of the things we cited centuries ago about the differences between interpreted languages and compiled languages. But that kind of stepwise refinement, that iteration, is really important. And of course, with the scripts, it's much more linear. You're writing everything out, you're running it, and then you're kind of looking at the end result, and then backtracking and kind of reverse engineering where you might make changes. The interactivity is gone there, and data preparation maybe even doesn't kind of capture the fact that it's not just a task or a necessary evil to kind of get to the analytics or get to some of the other things that we'll talk about shortly. it is actually, in some ways, maybe in a lot of ways, it's the very kind of sweet spot of the whole process. To me, transforming the data is analytics, or certainly there ought to be a tight loop between changing the structure of the data and analyzing it, and because one gives rise to the other.
Oh yeah, I totally agree with that. I mean, like in the preparation, you're defining the analysis, very much so. I absolutely agree with that.
Yeah, and so having the interactivity that you spoke to, being able to see the data as you transform it, is 100% comparable to seeing the data as you analyze it. And we're past the days of old report writers where we had to design in a schematic way what the report would look like and then run it and see how it came out, right? We're in the world of BI tools that as we pick things to be in a visualization and a dashboard, we see them render immediately. So it makes sense to have that. There's also, there's more and more, there are different transformations that seem to arise repeatedly, and having to fashion those from scratch versus just being able to reference them from a palette of choices obviously brings efficiencies that otherwise we wouldn't have. And most platforms, I'm assuming Trifacta included, are pretty extensible. If people really want to write code, there's a way to do that and then kind of integrate it.
Oh yeah, if you want to write Python or Java, you can absolutely do that on our platform, and then there's more to come there too. Yeah.
Sure. And I guess the way some data scientists work when they're doing their machine learning work, they're in a notebook and they're doing bona fide prep in code and training their models, and it's all in kind of one fell swoop. So gosh, I guess that's a segue to say that data prep isn't just about going from lake to warehouse, going from raw to structured, going from source to a descriptive analytics style dashboard. It actually supports some other things that are very important with data. All the way on the right here, we have machine learning and feature engineering. Maybe you could actually kind of explain what feature engineering is and how Trifacta maybe supports it for those who want to do it. But also, this is all about data management. This is about curating it. It's about making sure that the data quality is high, that it's cleansed. And, in an age of data protection regulations, starting with the European Union's General Data Protection Regulation, GDPR, and now, as of a few weeks ago, 2 weeks ago, I guess, we have in effect California's Consumer Privacy Act, which is a U.S. analog, I suppose, to GDPR. We can't be accidental about the way we manage data, right? And I don't know. I'll let you finish your own sentences here.
Yeah. So on the feature engineering piece, I think the ability to orient data and essentially you're creating attributes or columns that are specific for different types of algorithms or machine learning models. So, examples of that could be binning, scaling, one-hot encoding, and we have a full set of transformations in the application that allow you to apply data science specific transformations, so your data can be ready for specific algorithms that you'd like to run. So, you take a single data set and, depending upon the algorithm you want to run against it, you might need to transform it 30 different times, depending upon what you're doing in the back end. And so that's a very common aspect of, data science and machine learning. And it's a core part of the overall workflow, that is in the machine learning process. And that's a big reason why you see a company like Data Robot acquiring Paxata, because, that is critical to any work, is making sure that data is not only clean, but also oriented for the data science workload that you're doing.
Right, absolutely. And maybe, we may see further consolidation. And in fact, we just published at GigaOM a report that I was involved with on data pipeline platforms. So we took note of, that acquisition and some others. I guess we saw Dell Boomi acquire Unify Software recently as well. Of course,
Yeah.
Unify was also in the data catalog world, not just data prep. But I can't really say whether Dell Boomi bought them for one, the other, or both. But yeah, it's critical to all this stuff, and even I would say even in the lake, before you get to a more formal environment, before you move away from the unknown unknowns to the known unknowns that you were alluding to at the beginning of this webinar, even there, doing some data prep on kind of an ad hoc basis is probably important. You may take something that's raw, but you may want to add some structure to it, or either for perpetuity or for just immediate need. That's really what schema on read is all about. And so at all stages in this life cycle, it's important to have a productive environment to modify your data and its structure. And unlike programming, I drew some parallels. Now I'll draw some differences, right? When you write code, especially in a compiled language, you almost never do, but you want to write it correctly the first time, have it run successfully, get your output, and move on. And to the extent that it doesn't, you have to go back and edit, and we call that debugging. I mean, it is debugging. We're kind of casting aspersion on it. You made a mistake, you're fixing your mistake. In the world of preparing your data, I don't think it's about mistakes necessarily. I think it's about, or even trial and error. It's really about iteration and discovery.
Yeah. Not a linear workflow by any means, right?
Yeah,
you think it's just like, I do this and I do that, you're going to be going back and forth multiple times. And then on your point earlier, a lot of times, majority of our customers, they were using Excel. And then when we come in and they get their hands on the software, they just never knew something like this existed. And it takes a process that would take, whether it's, months to days, hours to minutes. I mean, they're blown away by the productivity gains they get. And I think it's just not knowing that something else beyond Excel is out there. And this is the whole thing with big data. I think like even the name big data was wrong, because it's not the bigness of data to a certain degree matters, but it's more the variety and the changing nature of data that is the most challenging part for the majority of people that work with data.
Yeah, agreed. And, the joke was always that, well, what is big data? It's probably hundreds of gigabytes or petabytes, except that, that's what everybody says they have. And then it turns out that the reality might be different.
Just 30 different spreadsheets that they don't control the format of, right?
Yeah. To some people, it's big data if you have to hit page down and go to, the next screen's worth. It's a bit all relative. And again, I think what was big about big data was kind of where the ceiling was. You start out small, but if you start out small and capture something of value, then it needs to scale. And the bigger data platforms allowed that to happen. By the way, I was also going to say that even if you have a quote unquote mistake in your data prep, you may kind of stumble upon some interesting insight in your data that you wouldn't have gotten to otherwise. So perhaps one person's mistake is somebody else's insight. One never knows. But you know what? We are at the top of the hour now. So hopefully we shed some light on some of the nuances and some of the broad strokes and truisms in this world. And we started out talking about data warehouses and data lakes, but I think by the end of this, we got to a point where we were saying, ultimately, whatever it is you're doing with data, you're gonna need to, at the very least, tweak it, restructure it, optimize it for some particular analysis, and that's what data preparation is all about. You're preparing it for something. And it's not just one thing. It's not just going from a lake to a warehouse. So, Wil, thank you very much. You were very gracious in entertaining a lot of the questions and the musings that I posed to you, and answering them in a really rich way rather than a yes or a no. Well, it's good. It's good. It's to some people it's a little weird to be passionate about some of this stuff, but to me at least it is the very crux of getting the work done, is if you can work productively and really enjoy the rigors of just the things that are foundational to eventually getting to the analysis. So you guys do a lot in that space, and it was good to be able to get into it and talk about it. So thank you again, Wil, and thanks to everyone in the audience for attending. Please join us on our future webinars as well. For GigaOM, this is Andrew Brust signing off and saying thank you once more.
Great. Thanks, Andrew.